Download this code from codegive.com, link in the description below. Sure. Let's dive into the concept of gradient descent and its variants. This tutorial will be divided into two parts. In part 1, we will cover the basics of gradient descent, how it works, and provide a code example to illustrate its application. Part 1, Introduction to Gradient Descent. What is gradient descent? Gradient descent is an optimization algorithm used to minimize the cost function in machine learning and statistics. It is a first-order iterative optimization algorithm that helps find the minimum of a function. In the context of machine learning, this function is typically the loss function, which quantifies how well the model is performing. How gradient descent works. The basic idea behind gradient descent is to update the parameters, weights, of the model in the opposite direction of the gradient of the loss function. The gradient is a vector that points in the direction of the steepest increase of the function. By moving in the opposite direction, we reduce the loss. Steps involved in gradient descent. 1. Initialize parameters, start with random values for the parameters, weights. 2. Compute the gradient, calculate the gradient of the loss function with respect to the parameters. 3. Update parameters, adjust the parameters using the gradient and a predefined learning rate, backslash alpha backslash theta equals theta, alpha nabla theta, where theta parameters, weights, alpha learning rate, nabla theta, gradient of the loss function. 4. Repeat, continue this process until convergence, when changes in the loss function are smaller than a threshold or a maximum number of iterations is reached. Example, gradient descent in Python. Let's implement a simple example of gradient descent to minimize a quadratic function f x equals x caret 2 backslash. The minimum of this function is at x equals 0 backslash. Explanation of the code. 1. Function definition, we define the function f x equals x caret 2 backslash, and its derivative f x equals 2x backslash. 2. Gradient descent function. We initialize x at the starting point. We compute the gradient and update x using the learning rate. We store the history of x values to visualize the steps taken. 3. Parameters, we define the starting point, learning rate, and the number of iterations. 4. Visualization, we plot the function and the points where gradient descent steps were taken. Conclusion. In this part, we introduced the concept of gradient descent and provided a simple implementation to minimize a quadratic function. In part 2, we will discuss variants of gradient descent, such as stochastic gradient descent, SGD, mini-batch gradient descent, and momentum, among others. Feel free to ask any questions or request specific topics for part 2.